Hello, my phenomenal viewers. Are you a student who finds it difficult to solve questions on integration involving trigonometric functions? Then I will recommend that you stay and watch this video till the end, because after watching this video, then I believe that that difficulty would be resolved. So on today's episode, we would be answering this GCE 2021 question, which is on integration of trigonometric function, and this question corresponds to question 6a. So the question has asked us to find the integral from 0 to pi on 3 of cos 3x all that to the power 4 sine 3x dx. So looking at the integration given to us, it is a definite integral. Why is it a definite integral? Because the limits of integration have been given. The limits have been given, which is from 0 to pi on 3. So whenever these limits are given, then the integral becomes a definite integral, meaning that at the end, we need not to introduce the constant of integration. So now, looking at the function that we've been asked to integrate, we see that we have the product of two functions. So cos 3x all that goes to the power 4 times sine 3x dx. So this cos 3x raised to the power 4 is a function of a function, because cos 3x is a function on its own and it has been raised to the power 4. So now, from what I know, we have two main techniques or methods through which we can solve this question. The first one is using the substitution method, and the second one is by using the formula method. Now, I would like us to solve this using the formula method. So, when you look at this function, like I said, it is the product of two functions. So, whenever you have the product of two functions, the first thing that you need to do is to check whether one of the functions can be expressed as the derivative of the other function. So what does that mean? You know that when we differentiate cos 3x, we are going to have something in terms of sine 3x. So it shows that this sine 3x can be expressed as the derivative of cos 3x. Now, the formula that I'm talking about is this formula of integration, which states that the integral of f of x raised to the power n times f prime of x dx is equal to f of x raised to the power n plus 1, all this divided by n plus 1. That's our constant of integration, since this integral is an indefinite integral. So now, what we are going to do is we are going to rearrange or restructure this function in such a way that we are going to obtain something like this, so that at the end we are just going to quote this integral. So this shows that we are going to have the integral from 0 to pi on 3 of cos 3x, all these raised to the power 4 is the same thing. I've not changed anything there, sine 3x dx. So now I know that this is the function f of x. Now, what is the derivative of f of x? So the derivative of cos of 3x dx is equal to, for me to differentiate this, I just need to differentiate the angle. When I differentiate 3x, I'm going to have 3. Then when I differentiate now cos, I'm going to have negative sine. So it shows that the derivative of cos 3x will be the product of the derivative of the angle and the derivative of cos. So this gives me negative 3 sine 3x. So it shows that the derivative of this function cos 3x is negative 3 sine 3x. So I'm going to rewrite or restructure this sine 3x to have negative 3 sine 3x. And how can I do that? I can do that by simply multiplying this function by negative 3 divided by negative 3. Remember, negative 3 divided by negative 3 is 1, and when 1 is multiplied by anything, the thing remains unchanged. So this simply means I'm going to have negative 3 divided by negative 3. I'm going to send this negative 3 in the numerator to make this sign 3x this way. So this becomes integral from 0 to pi on 3. I have my negative 1 then outside cos 3x raised to the power 4 into negative 3 sine 3x dx. So that is how I have rewritten this function. I've not altered anything. I've just rewritten it in another manner, which is the same thing as the function. So now looking at this function and comparing it with this, it shows that my f of x is cos 3x, my n here is 4, and my f prime of x is negative 3 sine 3x, then my dx is there. So since this holds true for this function, then it shows that this integral will become, remember we have our negative 1 third outside, do not forget that negative 1 third, it is a constant, into, it states that when this condition holds true, then the integral would become f of x, which is what? Cos 3x raised to the power n plus 1. My n here is 4. 4 plus 1 gives me 5. All this divided by 5. So this is what I have as the integral. Then I have to substitute now the limit, which is from 0 to pi on 3. So when I do the substitution, this becomes negative 1, 15. Since this 5 multiplies with this 3, I have negative 1, 15 into, and I substitute the upper limit. I'm going to have cos of pi, which is negative 1, minus, when I substitute 0, cos of 0, which is 1. So this gives me negative 2 times negative 1, 15, which gives me 2 on 15 as the value of this integral. So it shows that the value of this integral is 2 on 15. So that is how you solve this question using this formula. And this formula is obtained through the process of substitution. So like I said, you can either decide to go using the substitution method or using the formula method. For the formula method, you just need to restructure the function to look like this. Then at the end, you code that. So if you liked this video, please do not hesitate to share so that it can get to many students as possible. And if this is your first time coming across any of my video, please do not hesitate to either follow me or subscribe so that whenever I upload videos like this one, you would be notified. And thank you for watching. Stay blessed.